Hi, welcome to Sachin Study Tech. Today topic is Dijkstra's algorithm. Already previous video I discussed about Dijkstra's algorithm. So how to find out the shortest path from a one single source shortest path from one vertex source initial vertex to all other vertices. So in that example, we can consider the undirected graph. Now we can see the directed graph here. This is a directed graphs. So how we can find out the single source shortest path from all other vertices. So I am consider one is the here this is the source vertex. Then you can find out the distance from this source vertex to all other vertices. Now we can see in our algorithm, so initial vertex it is a cost is 0, so cost of this vertex is 0. Now we have to find out the remaining distance to remaining all other vertices. Now we can see, so it is visited vertex v, and what are the vertices is there 1 2 3 and 4 and 5 vertices is there in that graph. So here initially it is 1 is set to 0 because it is a source vertex. Remaining all vertices set to infinity. Now we can see here it is infinity, infinity. Here it is infinity. Here it is infinity. So this is the first step. I have to draw this diagram. Next step. So which is the minimum? Here vertex 1 is the minimum. So 1 is the visited vertex now. Now we have to find out vertex 1 to what are the vertices is connected to that particular what already visited vertex. You can see here it is 1 2 3, that is 6, already infinity is there. The relaxation here it is if d of u plus cost of u comma v less than d of v. If it is condition is true, then you can update the d of v equal to d of u plus cost of uv. Now we can see what is the, for example here it is u and here it is v. So d of u is 0 plus cost of uv. What is the cost of uv? That is 6. 0 plus 6 less than, what is the d of v? D of v cost is infinity. So 6 is the minimum. So we have to update d of v equal to d of u plus cost of uv. So that is d of v equal to 6. Now we can update. So 1 2 3, 1 2 3, that is 6. Here also see 0 plus 3, that is 3. Here infinity is there. 3 is the minimum. So you can update. It is 3. So you can see 1 to 2 there is no edge. So 1 to 5 there is no direct edge. So it is infinity, and 1 to 2 there is no direct edge. It is also infinity. So 1 is the already visited vertex. So which is the minimum? Cost of the vertex is here it is 4. So 4 is the visited vertex now. Now 4 is the visited vertex. What are the vertices is connected to that particular vertex? You have to find the distance. So here it is 1 is visited vertex and 4 is also visited vertex. Then you can see 3 plus here it is 1, 4, already 6 is there. So 4 is the minimum. 3 plus 1, that is 4. You can update it. This is the 4, and here 3 plus 1, 4. So here it is infinity. You can update it. Here it is 4. So 4 to 3 is 4 to 3 is 4. 4 to 3 is 4, and 4 to 2. 4 to 2 here it is 4, and already vertex 4 is visited, so no need to update it. And 4 to 5 there is no direct edge to 4 to 5, so it is a infinity. So you can select either this one or this one because both are cost of the vertex are same. So I am consider this is the 4, that is vertex 2. So 2 is the visited vertex now. So 2 is the visited vertex. Then you have to find the distance to other vertices. But here you can see, for example, you can see here it is, you cannot reach to 5. So 5 is infinity. Here also 4 to 5 there is no link. Here also 2 to 5 there is no edge to 2 to 5. So we cannot visit it to 5. So there is no path from 1 to 5. So here there is a distance 1 to 2 is 4 and 1 to 6 is 4 via 1 to 4 and 4 to 3. So that is 4, and also here it is 1 to 4, 4 to 2, 3 plus 1, that is 4. But there is no path 1 to 5. There is no incoming edge to the 5. So this is a problem here. For example, I am consider it is, for example, I am changed this vertex, here it is 4 to 2. Okay, 4 to 2. Now we can see in case of again you can solve that same problem. Now I am consider this is the edge 4 to 5. 4 to 5. Here it is 1 and 2, 3, 4 and 5. Here it is visited vertex V. So initially it is 0 and remaining all vertices set to infinity. This is the first step. So here it is 0, remaining all vertices set to infinity. Then so this is the minimum, you can select it, that is the source vertex. So you have to find out the distance from source vertex to all other vertices. Then here it is 1 2 3. So already 0 plus 6, that is 6. 6 is the minimum, so infinity you can update it, 6 is the minimum. Here it is 0 plus 3, 3. So here infinity is there, 3 is the minimum, you can update it. Here you can see 1 to 4, that is 3, and 1 to 3, that is 1 to 3, that is 6, and so there is no edge to 1 to 2 and there is no edges to 1 to 5. So that's why it is infinity, no change, it is also infinity. So already A is the visited vertex. Now what is the minimum cost vertex here? So this is the minimum cost. So that's why 4 is the visited vertex now. 4 is the visited vertex. First 1 is the visited vertex. This is the source vertex. Now 4 is the visited vertex. Now you can see this is the second step. Now the third step is, so 4 is the visited vertex. So here it is 4 to 3. Vertex 4 to 3. Here it is 3 plus 1, 4. So here the 6 is there. So 4 is the minimum. So we can update it. So here it is 4. And 3 plus 1, it is 3 plus 1 4, but infinity is there, so 4 is the minimum, so we can update it. So 4 to 2, that is 3 plus 1, that is also 4. So here it is 4 to 5, that is 3 plus 2. So already infinity is there, 5 is the minimum, so you can update it, 5 is the minimum, and 4 already visited vertex, no need to find out the distance here. So which is the minimum? So I am consider the 4 is the minimum now. So 2 is the visited vertex. 2 is the visited vertex. Now we have to find out the distance. Here it is 2 to other vertices. So here the 3 is the unvisited vertex and 5 is also unvisited vertex. So 2 to 5, 2 to 3 there is no edge, direct edge. here it is 2 2 3 2 2 1 and 1 2 3 is there, but already it is a minimum. So you can see here it is 2 2 5, there is no edge, and 2 to 5 is there is no edge, then it is a backtracking. So here 2 to 1 is there, but 1 is already visited vertex, so it is here it is there is no update. 4 as it is here, the cost is 5 is 5. Now you can see what is the minimum vertex here, it is 4 is the minimum cost, so 3 is visited now. 3 is visited now. You can see what are the edges is connected, what are the vertices is connected to vertex 3. So already 1 is visited and 4 is visited, so that's why you can see only 5 is there. Here it is only 5 is there, so this is also vertex, visited vertex is 5. So what is the distance from 1 to 2 is 1 to 2 is 4, and 1 to 3 is 1 to 3 is also 4, 1 to 4 is cost is 3, and 1 to 5 cost is 5. So how can get this least cost here? 1 to 2. So 1 to 2 there is no direct edge, but here it is 1 to 4, 1 to 4 and 4 to 2, 4 to 2. So 1 to 4 is 3 plus 1, that is 4. Here 3 and here 1, so that is 4. Next 1 to 3. So 1 to 3, here it is 1 to 3 is 6, but here 1 to 4 and 4 to 3, so that is 3 plus 1, that is 4. So 1 to 4 and 4 to 3, that is the least cost. Next here the 1 to 4 is 3, so direct 1 to 4 it is 3, 1 to 4 it is 3, so it is 3 plus 1, here it is 4, and it is cost is 3. And 1 to 5, so 1 to 5, here it is 3 plus 2, that is 5. So 1 to 4 and 4 to 5, so 1 to 4 is 3 and 4 to 5 is 2, so that is 5. So we have to find out the distance from source vertex to all other vertices by using greedy method. So you can see what is the drawback here. For example, this is the negative weight. If any graph consisting of negative weight is there, so you cannot apply the Dijkstra's algorithm. For example, here it is 0 initial, it is infinity, this is the first step. Now we can see A is a visited vertex, so here it is A and B and C. So A is initially 0 and remaining all vertices set to infinity, so A is the minimum, so A is the visited vertex here, visited vertex, vertex V, A is visited. Now we can see A to C, so 0 plus 2, 2, infinity is the maximum, so 2 is the minimum, so we can update it. A to C is 2, and A to B, 0 plus 5, that is here infinity is there, but 0 to 5, 5 is the minimum, so we can update it. So here it is 5. Now we can see which is the minimum. 2 is the minimum, you can see 2 is the minimum, so here is C is visited vertex, C is the visited vertex. Now so you can see there is no outgoing edge from C to any other vertices, so leave it. Now you can visit that vertex, C is also visited vertex here. Now only here 5 is there, so next one is B, B is the 5, but you can see, so A to B is 5, A to C is 2, but it is not a minimum. So you can see here it is A to B is 5, 5 minus 10, that is minus 5. So minus 5 is the minimum, so we can update it. But here you cannot find out here. So that's why any negative weight is there in that graph. So that is the drawback. You cannot apply the Dijkstra's algorithm. In this case, you can apply Bellman-Ford algorithm. Later class you can discuss what is the Bellman-Ford algorithm, what is the drawback of Bellman-Ford. Now it happens because in each iteration the algorithm only update the answer for the node in the queue. So Dijkstra's algorithm does not reconsider a node once it make it as a visited, even if the shorter path is exist than the previous one. So this is the drawback. So thank you for watching this video.